website. We are probably looking at one of the most commonly used professional sites that we have in the nation. When we look at our users, just to give you an idea of universities across the country and institutions that are using our site. So we've got the United States Air Force, the Navy, military all over. We actually had our website crash once because we had the Cuban weather service using our satellite pictures too much, and they wrote a script to download way too many images, and we had to block Cuba. So we have users from all over, all areas of the world as well, especially the military does that a lot. On average, our site receives about 38,000 plus, maybe 40,000 unique visitors, and we're putting around 10 million hits. So that's a pretty significant website, and we're transmitting, I think the average, this was last year, we were at 885 gigabytes of data that we transmit daily to our users. So we totally dwarf the rest of the college in terms of its net traffic. So I'm assuming that most of you are familiar with that. If you're using weather, you're probably using at least satellite radar, maybe some of the model pages. We can talk about that later too. So we're going to talk about the weather. So I'm going to start with the look back on the last couple of years of the 2019 weather disasters. If you do kind of a web search on this, you'll find these images every year. They've been doing it for quite a while. They call it billion-dollar weather and climate disasters. So I'm not exactly sure why something is called a climate disaster, but it is what it is. So back in 2019, if you recall, we had some major severe weather in the central US in the middle of May. There were some pretty good tornadoes in various areas in 2019 moving around, although it was transported a little bit to the east with the major outbreaks. We had some significant flooding these kind of things are happening all the time. Didn't have a lot of tropical activity, although they did create a couple $1 billion with the Melda as a tropical storm, and then Hurricane Dorian. California, Alaska wildfires, those things are becoming fairly common to be billion-dollar damages. We shifted into 2020, and now the fires have moved further to the north. Pretty interesting fire weather situations in that area because it was really not built on a drought. It was built because it was too wet of a year. And there was so much growth that when that growth eventually dries, as it does every summer, it was huge amounts of fuel for those fires. We had some hailstorms, again, central US tornado outbreaks. If you was a big hailstorm across South Texas, this year was pretty active with all the hurricanes. If you look, Hurricane Zeta, so we're already getting into the Greek alphabet. So that was an active year in 2020. When we get to 2021, I think the most amazing storm was this guy here, the winter weather one that shut down most of the Texas power grids. You had a number of severe weather outbreaks. You had some tropical activity, maybe more of a typical year. And there was scattered wildfires in the West. Again, they're putting it to $1 billion disaster, but you're looking at fires across many different states to kind of call it that Western wildfires. We did have a big derecho and tornado outbreak in December. That was kind of a crazy thing. Some hailstorms. The East didn't seem to have too much that year. So those are just some pretty interesting facts when you look at it this way. And Hurricane Nicholas, yeah, I just wouldn't trust anybody named Nick. So when we talk about tornadoes, right, the climatology of the US is on average of around 1,200 tornadoes per year. Here's 61 years of tornado tracks. I love this. It's just a really cool image, but it really sets up the idea that there's no area that's completely safe from tornadoes. You will see a couple of tornadoes even in the desert Southwest, probably more than have been listed, but they're not really out there doing anything, so nobody's reporting them. Central US, and what's really interesting is that some of the brightness is the EF rating on this. And if you look at this deep south, this is the area that's really highlighted with some of the big major tornadoes. And this area, what do we call this basic area? This is going to be Dixie Alley, right? And these are sort of colloquialisms where we just, oh, Dixie Alley. But really, when you look at tornado threat, the South is extraordinarily vulnerable to major tornadoes. And there's going to be several reasons for that, which we'll talk about. The typical tornado alley is across the central US. When we go up in the Dakotas into Wyoming, Montana, and we're talking about 61 years of tornadoes, this area probably gets more tornadoes, certainly up into Canada, than we are representing. But until the storm chase craze came in the mid to late 90s, we really didn't get many people out there observing or probably reporting tornadoes in the Dakotas, and they're pretty abundant. I'll have some stories to tell you about tornadoes. Now you look into Illinois and you'll see some really bright areas around the Chicago metro area. And if you start looking at the significant tornado data down to the detail of the counties, you'll find that McLean County is pretty much a hotspot within Illinois, and that's where Bloomington is. So we are right in the Central Plains in this tornado alley, extends into Indiana. I'm a little disappointed because usually this year we get, or usually every year, there's one big outbreak of severe weather sometime end of October, early November. And I suppose it's possible we could get something as we start getting some Western troughs, but the last few years have been sort of disappointing because of La Nina out there. So let's kind of dial down into tornado frequency and looking at all tornadoes. That definitely shows you this hot spot across Oklahoma. There's no reason to suspect, why is the SPC, the National Severe Storms Lab, why are they out in Oklahoma? Those areas here were ground zero for most of the research since the 1980s. Anybody know what the first area of research was back in the 50s for thunderstorms? You know, if you've seen like three stages of a thunderstorm's development, the cumulus, the mature, and the dissipating, those pictures, anybody know where that came from? What project that was? That original project was actually centered over Ohio. So if you ever go into some of the severe weather indices like the Showalter Index, or you look at the sweat index, everything's at 850. 850 was a pretty good way to go above the boundary layer when you're in the lower regions of Ohio. You bring that information, those type of indices out to the high plains, and it's going to kind of not give you a real good flair for why those indices are important. I had once done a big outbreak analysis of the 1974 tornado super outbreak, and those indices like the Showalter and the sweat index were a lot more used back then. Now we have different tools. So when we look at the deadly tornadoes, certainly Oklahoma's got a lot, but notice that there's a pretty significant centering across the Deep South into what we call Dixie Alley. All tornadoes and even the deadly tornadoes across Indiana, Illinois, a lot of this would have been with the 1974 outbreak. That extreme event sort of takes the statistics up high. Barneveld, some of the big, I think it was the Monticello tornado across Indiana was big in 74. But significant tornadoes definitely has a shift to the east across northern areas of the mid-Mississippi down to the Tennessee-Ohio Valley. And we get these big outbreaks through Mississippi. Those are the ones that we're dealing with normally in spring. So when we're looking at that, we say, well, where are people actually getting, where are the fatalities occurring? And number one reason is mobile homes. So when we look at the significant tornadoes in the Deep South, in Dixie Alley, and we couple that with when these tornadoes are occurring, which are going to be almost at the end of the cold season into the beginning parts of the warm season. So we're looking at maybe February, early March as having some significant outbreaks. We are looking at a very vulnerable area because there's a majority of people live in what we've been calling mobile homes. And that may not, if you've been to the South, it's not really mobile homes like a trailer, but it's more like the prefab houses that sit on cement cinder block. And those type of houses are going to be very vulnerable to these tornadoes. Couple that with longer dark periods. So you've got significance in terms of the tornadoes in the evening and overnight hours when people are either in their homes or in bed. It's dark. If you've ever wondered, how many of you have gone storm chasing? I'm looking over here. Okay, so if you've gone chasing, do you ever chase down into northern Mississippi? Okay, that's just not an area that you want to go to very often because there's so many trees. You have no ability to kind of see stuff that's coming. It's challenging. It's annoying, in my opinion. I like to be on the plains when I can see my dog run away for a couple of days before I lose track of them. But over here, I've got lots of trees, a lot of hills, overnight storms. It's early season, so they're moving fast. It's just a dangerous place in people's houses. Now, permanent houses have a better number, but still a pretty high significance about where the fatalities are occurring. And that would be true of maybe some of these other types of weaker houses in the South. And then vehicles are bad. Now, I don't know what you guys are taught at Western, but I teach my students, if you're in a tornado in your car, should you get out of the tornado and go into a ditch? What do you think? What do you guys think about that one? What would you do if you were in a tornado in your car?
I'd always say get out.
I would get out. I don't want to shoot her, but I don't want to be in a car.
See, here's where I don't know if this is necessarily a good thing, but you have to kind of think what is going to be the best thing to do, and you have to actually make a decision. And I would suggest drive away from a tornado. And for some reason, people say, "Oh, you can't outrun a tornado," and the answer is, "Well, yeah, I can." Now it depends, though. If I'm running away from it in some open rural highways, I have no problem. Tornadoes over there, I turn around and go away from it. It is not going to catch me. And if a tornado is going at 70 miles an hour, I can still do that. But if I'm stuck in my car and I'm sitting here in the Chicago metro area in rush hour, where, we don't measure things in miles. How many people are from the Chicago metro area? See, we don't measure, how far away do you live? You don't say, well, 15 miles. We say, well, that's 34 minutes. Everything's measured in time. So when we've got those situations and we have no place to drive to because there's gridlock or traffic or whatever, then I'd say get out of the car, go to a house. But unless I'm in an extraordinarily bad situation, I would not get out of my car. I would drive away from this thing. Now, I suppose if it's super, like I've got 15 seconds, I would get out of my car and jump. I certainly wouldn't want to be in a tornado during that event. So this was at 2022. This was as of a couple of weeks ago. Well, actually, this one was 2022. I don't think we've had any tornadoes of significance this entire summer. But 2022 is shaping up to be sort of in the middle over the last several years, where we have a maximum of 1,884 tornadoes. And then we've had lowest in the last several years was about 944. So we are really low. I don't think I updated this slide. I've updated some other ones since early this summer, but we've really had a extremely weak August and September in tornadoes. And I'm sorry, but I don't buy those tornadoes in Wisconsin. I don't know if you guys were talking about that. We should say something about the state of our field. We need to get a little bit better, and I think we're going in the wrong direction. So this was from a couple of years ago. This is kind of interesting. We had 553 deaths from tornadoes in 2011. Anybody know what tornado that one was? Like, what was the main tornado causing those huge numbers?
What year was Joplin?
That was Joplin. Yeah, so Joplin tornado, that was what a horrible tornado. Lots of people died. That was one of the worst years in record for that. But then we start looking at lately, 2018 had 10 tornado deaths the entire year. That was the lowest on record. So it's sort of all over the place with these events. Notice this one goes back to 80. We go back to 74 and some 315 people died on that one super outbreak. Now, if we look at tornado climatology in Illinois, you'll see here's the statistics since 1950. And you could sit there and say, and this is one of the things that's really important for you as students to understand. When you're going to present statistics, you need to make sure you know what's going into the data set. So in this example right here, you could make the inference, you could say, well, boy, if I put a best fit on here, there's going to be an increase, must be climate change, right? But this is not true. This is when Twister came up. And Twister made a huge difference in what people have done in terms of tornado chasing. Prior to 1995, there wasn't that many people chasing. We started in 89, and we could go around any place and people would go, what are y'all doing here? And we'd say, well, we're chasing tornadoes. I'm like, y'all crazy? And they had no idea what we were in the early 90s. After Twister came out, it became so common, everybody knew all the chasers. When we went out storm chasing in the early years, we would have a phrase known as storm chaser convergence. And when you saw other storm chasers on the same storm. So in 1992, 1993, we would say storm chaser convergence is 5 or 6 chasers on a storm. And we actually liked that. We talked to each other. Now, when we talk about storm chaser convergence, we could have well over 1,000 cars chasing one storm across the plains. It is, well, it's annoying to me. It's dangerous and it's kind of scary. But that started to get all these reports of tornadoes. So to make the argument that climate change is not showing an increase in tornadoes, we need to add the tornado reports. But this time we're going to go with the EF2 to EF5 tornadoes, what we call the significant tornadoes. And you will see that from 1950 across Illinois, we've seen, if anything, a slight decrease in the number of significant tornadoes. The weak EF0, EF1 tornadoes are being reported all the time. So understanding that database is vitally important to understanding what's the long-term climate-related trends in tornadoes. And we know that these are going to be tornadoes because in any year, we're probably going to have an incidence of them. In fact, you could make an argument there might have been more that didn't get the damage indicators of an EF2 because maybe it hit open fields. And with the population higher now in the 21st century than it was the middle of the 20th century, you're going to see maybe an adjustment of even more impact in terms of people and properties. And the same is true when we start looking at the climate statement for the last, 30 years, 20 years to tornado days. And this is actually in line with some of the research that I've seen. Dr. Gensini from NIU has done some of this, where the number of tornadoes is a fairly constant, maybe a little bit downturn, but we're actually seeing the tornadoes coming in more outbreaks. So it's not distributed equally. Like we'll have more outbreak days with higher numbers of tornadoes, but then we're going to get more days in between where there's nothing going on. And this might be just a short-term turnaround or maybe a longer-term trend, but we are actually seeing that in some of the data sets. The number of tornado days is going down. Now, I know you probably all know about the destruction of tornadoes where you start looking at it. How many of you have ever been on a tornado survey or have seen the damage of, let's say, a fairly significant tornado? Has anybody ever had a chance to do that? It's pretty amazing because you start to go, whoa, and you start to see what winds can do. Trees, Evidently at the Severe Storms Conference, they are going to be expanding to the damage indicator book to say, we are going to be able to say a lot more things. What does the damage look like? And what does that mean for the strength of the wind? So I don't know if that's good or bad, but we're going to get more. And we always get these pictures of people's lives impacted. Aluminum siding wrapped into trees is something else. School buses rolling. You know, this is another thing. School buses and tornadoes just don't mix. So if I were in a school bus, I would get out of that bus and get in a ditch. So I'm going to show you this one. This is kind of a fun video. It's a small one. I don't think I need to play it long. Now, why isn't it not playing? Oops. Or maybe it is playing. Are you moving, Tornado? Are you seeing this, guys?
No, it's not playing on our end.
No. Well, is this one going to play? Okay, hold on a second. Maybe I can find you this. I never understand. Sometimes they play, sometimes they don't. Oh, I'm going to have to. I'm sorry, Nick. I don't know why this is not working this way. Just give me a second here. Maybe I have just the video. Wonder if I could. Well, you know what? You guys have seen videos. So let's see, where are you all? Well, I'm going to have to do it this way. Actually, you know what? I can show you this one. I know this tornado. Anybody know what tornado this is? Oh, there it is. It's working. Anybody know that tornado? Okay, I'm gonna show you. I'm gonna show you this one again. Let's go here. Now watch this. Right there is an entire house. And this is a minivan flying through the air. So this was actually the strongest tornado ever in Canada. This is Elie, Manitoba tornado. It was considered their first F5. And you saw an entire house being destroyed and lifted by this thing. So this is what we sometimes call a drill bit. It's not moving very fast. It doesn't look like those huge wedges. It is just extremely strong. That is an entire house that got disintegrated in there. So I see what the problem is. There we go. So I don't have any controls on this, but at least I can play the movie just by clicking there. So here we're going to look at a house. This is a security camera. I think this one was in Iowa. Notice that the inflow winds are very intense. So the tornado is strong. Now we get the rear flank downdraft wrapping through it, and the winds change direction. That's putting a lot of structural stress on that house. Trees go bad, and then it gets really dark right before the tornado starts lifting the roof, and the entire house is going to disintegrate. So pretty amazing stuff there. This one is oh shoot, man, come on. Why can't these controls work? This is Fairdale. I'm going to let this go. Have you guys seen this Fairdale tornado video? Anybody? This is just an amazing thing. So there was this guy, old guy, named Clem Schultz. He's in his house and he starts filming this outside of his window. Now, the entire video, there's no sound from him, so you're not missing anything if you can't hear it really well. And he's just, all you do is you hear him breathing a little bit heavier as it gets nearer. He's not panicking. He's not saying anything. Notice the tornado is getting larger. That's usually a good sign. It's moving right at you. He's on the second floor of his house. I don't know why. Now his wife is on the first floor. And my biggest criticism would be like, why aren't you there with your wife, right? She's downstairs, I think in their kitchen. As it turns out, she's going to end up losing her life in this tornado. A neighbor across the street. Clem will be knocked out, but he will survive the tornado. And I think it's just one of those things he thinks, if today's my day, today's my day. But it gets some astounding video on this. And you get the idea that there's all sorts of incredible motions within this thing. You get some lightning. And it will also get louder. And that's the end of his house. Again, he just stood there and videotaped it. I have no idea how anyone can do that without freaking out, but that's what he did. But an amazing storm. This was an EF4 tornado that just completely obliterated anything. But you get an idea of how the wind continues to intensify. I don't know if you've ever done any tornado vortex studies, but we consider that a Rankine combined vortex, where the speed of the winds will actually go to the main vortex maximum, and you'll have an exponential growth. You could see that with the trees coming down and knocking things over. And then it's almost like there's an eye in the middle of the tornado with almost zero or linear decrease to zero in the center of the storm. Now, another tornado is pretty interesting. This was a fantastic day, June 20th, 2021. Was anybody involved in the Woodridge tornado? Anybody from the Woodridge area in Illinois suburbs or Chicago suburbs? So it went from Naperville to Willow Springs. It was an EF3 tornado. And this is the kind of thing we start seeing. We start seeing these debris signatures where we get some correlation coefficient dropouts. Interesting story to tell you about this day is I'm watching storms coming in, right? It's a line of storms. We're not thinking tornadoes. I'm not even sure if there was a tornado watch, might have been, but whatever. And I hear on the radio a tornado warning. And I'm enjoying the lightning because we don't get thunderstorms around here very much anymore. So I ran upstairs to my computer, go online. I'm looking at it going, oh, that's a CYA tornado warning. You guys know what I mean by CYA? Cover your ass, right? That's what you're doing. You're like, well, there might be a tornado in there, blah, blah, blah. All of a sudden, I see this on the radar signature, this correlation coefficient. This is part of the things that you do to call it a debris signature. There's another smaller one over here, and it's great. It's lofting debris, but it was a very significant rotation as indicated by Doppler radar. So it did a great amount of damage. That was one of the most significant tornadoes on a Sunday evening. Nobody died, but there was some amazing storms there. So when we look at thunderstorms just generally, here's the distribution of thunderstorms. Again, keeping in mind that the mountains are going to be generating thunderstorms in the summer almost all the time. But there's definitely toward the southeast, especially the peninsula of Florida. So the state with the most thunderstorm days is Florida, which I think is ironic because what's the nickname of Florida? The Sunshine State. So it could have been the thunderstorm state, which would have been really cool. I think I would have moved there if they called it that. When we look at lightning as a major fatality, right? We're looking at, here's 1959 to 2017. We're seeing some states, Texas, Florida, most thunderstorms, a lot of outdoor people doing a lot of outdoor activities, high amounts of death rates. Illinois, 104 in that time period. So it's still a pretty significant threat. We can look at a couple of things with Vaisala's NLDN, National Lightning Detection Network. And then this map again shows where's the greatest flash density. So we can look at some of those areas here in Florida. Now, let me do this. I need to move you here and I want to open up a window because I want to show you something. I don't know if how much of this you've used. So are you seeing this right now?
Yes.
And I need to go to our satellite page. And I'm just going to look. I don't know if there's anything exciting. That's not what I wanted. I don't know if there's anything exciting going on in the country right now. No, there's not. So what I probably need to do is I need to go back to yesterday, where we had some of the bigger thunderstorms across the plains. So I want to show you something here on this. And instead of this, I'm going to go to, oh, I don't know, let's go to visible. We have on here an overlay of products. On this, we have the GOES derived. So we do have flash density, which should go back to yesterday. So this is something, I don't know, you may have seen that that satellite can actually look at flashes.
Hey, Paul, we can only see your email right now.
Oh, you're looking to my email? Wait, where are you at?
I see your mouse, there you go.
You see this?
Yeah, now it's in.
Oh, so do I have any good email? I don't know which screen is being projected. I thought it was projecting that one. Okay, are you seeing the satellite here?
Yes.
So we have the GLM flashes, and then we have this thing called flash density. So we can actually look back and see where some of the major flashes are going. So the satellite is actually being used for this. So if I can take off the flash density here, and you can see the flashes. It wasn't a big electrical event yesterday, but it was kind of fun. Last night or early morning across Georgia, more information. But we do have products now that we've added just within the last couple of months on flash extent density, which is really interesting. If you want to start looking at some of the latest research on flashes, we can look at total optical area for that. And we can look at the flash area, which says dying MCSs that are going to be having a lot more anvil crawlers, that kind of thing. So play with this. If you go up here to the product overlays, you will see all of this stuff with lightning, which I think is going to be kind of cool. I don't know if you've used that kind of stuff in the satellite description. I mean, we have mesoanalysis, SPC graphics, but this GOES derived stuff is amazing. We can also go into a couple of more things on the GOES derived, where we can look at cloud top temperatures. Let me go backwards. We can look at the amount of CAPE in areas that maybe aren't affected by clouds. We can look at rainfall rates. Lots of tools are embedded on the satellite page for additional analysis if you're ever into that kind of thing. So I wanted to make sure we were looking at that. Okay, Severe Weather Club, that's your email. Let me get back to this. What do you see right now?
In the presentation.
The actual presentation?
Yes.
Not this little next slide thing, just the.
No.
Okay, beautiful. Good, then we got that. Okay, let's talk a little bit about flooding. That is going to be the most common natural disaster worldwide. About 40% of all natural disasters are related to flooding. And in the US, it's going to result in about 200 deaths per year, making it really the deadliest aspect of weather outside of major events like Katrina. But even Katrina was with hurricane flooding. Now, I wouldn't call it a flash flood, but that was certainly water related. And over the 10-year period from 1988 to 1997, we're looking at about $3.7 billion per year of damage due to flooding. And 50% of flood-related drownings are vehicle-related. So what does the Weather Service say, for those of you in emergency management? Turn around, don't drown, right? Super important that you do that. When we start talking about flash flooding, it could lead to significant river floods. We had this event last couple of days. We had some heavy rains, really didn't have much flooding concerns, maybe some urban and small streams advisories. But for the most part, didn't have a lot of flooding. We had a fairly dry period in fall, which we'll look at coming up. But when we look at the multi-sensor precipitation amount that I'm showing you here, this is an amazing one. This is just April of 2013. And a lot of these areas are 4 to 8 inches or even 10 inches of rain. It wasn't just from a thunderstorm. It fell across the entire northern half of Illinois. So if you were around in 2013, maybe in parts of Iowa or Missouri or even Indiana, that was a major hydrologic event. We had record high flooding at the Illinois River near Peoria. So this was just a major event for river flooding. Now, other threats that we can talk about are hail. I like this picture. It's the hail days per year. And you'll see that the high plains into Colorado and Nebraska are your big severe weather hail days up in the Dakotas and the Black Hills. But if you look across northern Illinois, we actually have a pretty good high amount of hail days, somewhere coming in 5 to 8 days per year of severe hail. Annually across the US, that's going to be $1.3 billion of crop damage and $1 billion of property loss. There's a lot of work going on at the Severe Local Storms Conference going on in Albuquerque right now. And you want to know how good are you guys at forecasting hail size? Anybody good at it? Because if I asked that at the local storms, they would all go, yeah, nobody's good at it. We have no idea how to forecast hail size. We might be able to look at when we're able to get large hail or severe hail. We can't determine whether it's going to be 1.5 inches or 5 inches. It is amazing. So there's a huge push in research right now going on to try to understand hail because we suck at it. And they're actually doing some really cool things. I heard about stuff where they're doing high-speed cameras with incredible lights and hailstorms. You can actually do high-speed photography to see the speed of the hailstone, the amount that it's turning around. These are estimates of around updraft speeds for baseball hail is around 81 miles an hour, but the speed coming down, baseballs, if they're dense, maybe coming down at 70, 80, 90, 100 miles an hour, some of the big ones. So getting hit by a baseball at 100 miles an hour, that would not feel good. The other thing that we worry about is this. What is this long-lasting windstorm called?
Derecho.
That's a derecho, right? I don't know if you've heard where the term derecho came from. Back in the late 1800s, a lot of people were coming out from the East Coast into the Midwest. And people were getting very afraid of tornadoes, especially as they were moving to Iowa. So there were some people in Iowa that says, we need to try to convince people not to be afraid of tornadoes. Now, tornado is a word that means to twist or to turn. And they were doing some research going, these aren't tornadoes doing a lot of damage. These are straight ahead winds. So that's where the term al derecho comes from, that you're going straight ahead. So they started calling, no, we don't have tornadoes, we have derechos. And nobody was afraid of derechos. So more and more people came into Iowa. And they should have been afraid of just Iowa. This is an area up north. These are actually trees, if you can kind of make out the fact that all these trees have been felled by these incredible windstorms. There was an area called the packwash. So sometimes you'll hear these derechos or these blowdowns known as packwash storms. You get these cool clouds coming through with derechos. I think this was from Illinois where we had just this really cool shelf cloud, very strong winds in there. Back in 2012, across the Midwest was the super derecho. This was an amazing event. It started with severe weather in the collar counties of western Chicago and started doing damage. And then it became a storm that went all the way into the Atlantic. it traveled 450 miles in 6 hours for an average speed of 75 miles an hour. The one that's a little bit more recent that you may be remembering was what happened August 10th in 2020, where you got these line of storms early on in the morning that became this wicked storms. There were storms in Iowa that were what, 120, 130 mile per hour winds. They then did this little, they started to bow out. When you see the north end vortex coming in there, you know that the Coriolis force is starting to play a role, right? We usually don't think of Coriolis forces as being significant on the mesoscale, but this becomes a larger scale event lasting for several hours. And so we get an asymmetry in the line, and we got a lot of significant damage across Illinois before they started to break up, and then actually created a number of tornadoes, what we'd call QLCS tornadoes, or quasi-linear convective system tornadoes, but a very impressive line from 8 a.m. to 7 p.m. Another famous incident was this one, which was the Missouri duck boat accident. So if you remember this one, they do these boatings on the lakes, and there was severe thunderstorm warnings. And evidently the story is that the pilot of the boat said, "Oh, I see it. We'll make it back before the rain hits." And what they were looking at was the echoes showing up on radar. But if you look at this fine line out ahead of it, this is the outflow boundary. So these are where the winds were being experienced. And somebody without a meteorological background was looking at reflectivity. That's how a lot of people think. Oh, that's where the storms are. This is where the winds were. So that boat was capsized. And I don't, do you remember, anybody remember what it was? 17 people died in this event. When we look at severe weather, this is kind of interesting. We always think of the central US as being our big days, but when it comes to severe thunderstorm wind days, at least from this time period, we see a favoring of that across the Carolinas and the Piedmont and the Appalachians. So pretty interesting. When we talk about severe winds in terms of its May, in terms of monthly output, we actually see that June to July are your biggest days. Now, this is out of Jackson, Kentucky. I couldn't find really cool data anywhere else, but gives you an idea of the Midwest, that we get these big lines of storms, coming out of the Northwest on that Northwest flow in the summer. Now, in Illinois, the average monthly wind speed is listed here. So we are about to go into one of the windier months as we go into November, but the windiest is going to be our March and April. Last thing we'll talk about, this is a Chicago snowfall. I like this diagram because it shows you that we can get measurable snowfall in Chicago sometime in October, but as we go into November, we start to really increase the odds by end of November. Last couple of years, we've been in La Nina. La Nina has been very annoying for our weather. I would say in Illinois, what's happening is we start out with fairly mild weather for this November, December time period, and then it gets really nasty in the mid-January, January, February, March. Winter weather hazards, here's where your ice. So again, now this time, New England, the Northeast starts getting their share of ice storms. That's their real weather. Their winter storms are really big, but we have quite a bit across the Midwest. So right across central Illinois, in through Iowa, Minnesota, western Minnesota is where our highest threats for ice storms are going to be. Talking about climate, let's just talk a little bit about this. I like this one, Illinois temperature trends, where we look at average temperature. So we see that there is definitely a trend in this of about 1 degree Fahrenheit per century. Now, this always bothers me, and because my opinion is you don't know what climate change feels like. You don't. 1 degree per century is not going to be something you're going to discern by your own experience. We can look at data, we can find this stuff out there, but it's really not going to be very much in terms of what we experience in the Midwest. Other places in the world, maybe you could make the argument for a person experiences climate change. But for us, I don't think you can tell the difference if it's 2 degrees Fahrenheit warmer than 50 years ago. You're just not going to know what that's like. You look at the annual precipitation, there's a little bit of an increase, but not much. Here's something that's really interesting. When we look at winter precipitations, we are seeing basically a very flat line in precipitation. Some years are more, some years are less, but we see kind of a straight line of that. But when we go to summer precipitation, we see the increase. So what's the reason for this? Well, the number one reason, and I guess you could call it climate change, but it's not CO2 or pattern related as much as it is land use. We are getting 2 to 4 times more crops per acre. And a cornfield or soybean is a very good transpirer of water vapor. We are increasing the low-level dew points, which is making the atmosphere more unstable. So our summer precipitation is going to have higher amounts of thunderstorms. And so when we start talking about climate change, we have to be, again, go into the data and say, well, what's the reason for this trend? It's not the winter, it's the summer. It's the crops that we're planting across the soy belt and the corn belt. So here's some El Nino stuff. You probably have dealt with El Nino, La Nina. It gives you some idea. I'm not even sure what years you should be looking at for some, whether it's going to be above normal or below normal. I think we do a bad job at forecasting what we call the sub-seasonal range in the 1 to 3 month period. So this I brought online yesterday as the 24th. We are in a La Nina continuing. This is crazy. This is our 3rd winter going into this La Nina. Very cool to see this. We do have some animations of this if you want to go back for several months to see you'll actually see the waves of cold water. We have this blob of warm water across the northern Pacific, cold water across the Atlantic. What that's doing is it's decreasing the north-south or the meridional temperature gradient across the western Pacific. And so your jet stream doesn't extend during these events, doesn't extend very well, and it breaks down into cutoffs. So because we have these cutoff lows, we tend to end up ridging across the west, and that's going to connect to a troughing in the east. And that's what we've been seeing this year. Warm and dry in the west, cool and moist in the east. And that's because of what's going on in the tropics. Most of the experts will tell you global climate experiences are going to be impacted by what's going on in this region more than any other region in the country. Here's the latest drought monitor. You can see the impacts of that drought. This was as of June 2022. Interesting thing, if I show you what's happened as of last week, the drought in the Southwest has been ameliorated or made a lot less due to the fact that the monsoon seasons were very high. California is still in the valley, very drought stricken. We've seen an increase. I'm going to go back for a second. We've seen an increase in the drought conditions across the plains in the Midwest. Illinois stays fairly decent, a little bit of drought, but this was as of October 18th. So take a look at this area here where there was some drought. And this was the 24-hour multi-radar, multi-sensor precipitation estimates. So parts of Missouri and central Illinois, as of, I don't know what time is it, 21Z yesterday, were pretty high. I haven't looked at what's coming up or what happened after 4 o'clock yesterday, but you get the idea that some of those drought-stricken areas are going to be kind of eaten into. The soil content will be pretty much better, at least across the Midwest. If we look at our 10-day rainfall forecast, a lot of this stuff was from the event yesterday. Still getting a lot of precipitation out in the Atlantic, like who cares? But notice that the Northwest is now starting to get their share. So we're starting to bring into winter weather. So all these images are stuff that's available on our site, and I will show you that in a second. I'll leave you this. If you're interested in chasing, you can take a look at this page. Or you could talk to Nick about this, because I know Nick's going to be chasing with us again. Pretty cool storm here. So I thank you for your time, but I do want to show you one more thing here. Are you looking at this satellite page? Okay, so we have a new text page that we are experimenting with. And all those images are going to be displayed here if you're into droughts or fire weather or something along those lines, right? Here's the latest information from the drought monitor, but you can go back and we do animate these kind of things. I think we can go back pretty far at this point because we've been generating them fairly recently, but it gives you an idea of the changing weather patterns and the influences of the drought over the course of time. We also have hydrologic, so I can look at what was the last 24 hours of precipitation. If I wanted to say, well, how much has fallen with that whole event over the last 3 days, we do some graphics. So a pretty good amount of rain across most of Illinois. Western, I don't know, you probably got about 2 inches somewhere in that, in Macomb out there. So it kind of bites into it. The northern plains and further to the west, still being fairly dry. You can take a look at this anytime you want, but I want to promote a couple of things. The hazards page, I really like this one. I think this is better than what the Weather Service with their what they call WAWA Weather Watch Advisory, because you can tune into multiple ones, see what's going on. You could go in here and click. Let's go to this area. You can read what the warnings are. And these things are updating every, what, 30 seconds. So you get some idea. We also have the weather forecast office. This is where we're headed to with our text page. So if you, I don't, which, are you in the, what office are you in? Lincoln? You're in Quad Cities? I'm sorry. Quad Cities. So looking at your zone forecast here, you can fairly easily, if you wanted to, just find where you guys are. I don't know how easy. It's a big area. Did I miss it? Macomb, there we go. You get your zone forecast, area forecast discussions. We're trying to break the text products from the Weather Service into these regions. So this is a page that we're really working on, trying to update our website for this. It's a big project. There's a lot of text coming from the Weather Service, but we try to give you access to it. I can't be a teacher without telling you what I think about things. I try to tell my students, get into the habit of reading AFDs. I don't know how your Lincoln AFD is. Am I still sharing screen?
Yeah.
Okay, I want to stop share. That's what I want. I try to get into the habit of reading the AFDs. I don't know how your either Lincoln or Quad Cities AFDs are. I know Chicago's got some of the best discussions I've read, and consistently they're really good. If you want to learn how to forecast, how to put together information, how to communicate that, skills for meteorology, right? Get into the communication game. Figure out ways to get that information out to you. Read those discussions. I'm sure those of you in severe weather, the Severe Weather Club, you read SPC. Sometimes SPC is great. Sometimes it's like kind of crappy. Let's just be honest. If you read stuff by Roger Edwards, it's like having a professional tutor telling you how to look at weather information. So get into Roger's stuff. Anyway, are there any questions that we can talk about?
I think we don't have any questions.
If you ever do, feel free to write me. Be more than happy to answer that stuff for you. I'm hoping that someday maybe I can get out to Western and we can do this again in person.
Sure, yeah. Thank you, I really appreciate it.
Okay, great, guys. Thanks. Have a great night.
Thank you. Thank you.
Bye, y'all.
Our organization. They're going to their channels. Okay. Yeah. At the end of the meeting today. Thank you for coming.